Hello guys, so in this video we will be going through problem 4 from the module 2 not packet. In this question, a bullet starting from a velocity of 367 meters per second accelerates into a lump of clay and moves 0.0621 meters inside the clay, and we are asked to calculate the acceleration of the bullet. To solve this problem, you must make some assumptions that are not explicitly stated in the problem. You need to assume that the lump of clay is anchored so that it doesn't move, and the final state has the bullet at rest. So let's start by defining a coordinate system. I'm going to have right as positive. You can choose either right or left as positive. It doesn't matter as long as the system is clear and consistent. Now let's see knowns and unknowns. We do know the initial velocity, and we know the final velocity, and we know initial position and final position. So let's take the initial position as 0. This is the point where bullet first enters into the clay, and final position is 0.0621 meters. And initial velocity is 367 meters per second, and final velocity, as I stated earlier, is 0. Now next step is to look at the two unknown variables. We don't know the time interval, and also we don't know the acceleration of the bullet. Okay, so now next let's draw a motion diagram. The bullet has an initial velocity of 367 meters per second and final velocity is 0. That means it's slowing down while moving to the right. So the dots of the motion diagram should be spaced closer and closer to indicate that the object is slowing down. Okay, so now let's look at the symbols of what we are trying to find and expected sign. All right, so we are trying to solve for the acceleration. So right, the symbol of acceleration is A, and the unit by now you know it's meters per second squared, and then the sign. Okay. So bullet is moving to the right, and that means velocity of the bullet is to the right. However, the bullet is slowing down while moving to the right. That means acceleration must be in opposite direction to the velocity. Our coordinate system states that right is positive. So you can see it states right is positive, which means we should expect a negative number for the acceleration. Okay, so should expect a negative number for the acceleration based on our coordinate system. Okay, now let's look at the applicable concepts. So if you look at the applicable concepts, the bullet is moving in a straight line. So this is a 1D kinematics problem. And this is chapter 2.5 in your textbook. Okay. Now let's plan our solution. So when you plan the solution, you guys can see these are the 4 equations in your equation sheet. So or the module 2 notes, you see these 4 equations, and let's look at each one of them. So first one, it has let's see, we are trying to solve for the acceleration. So do we see an acceleration in this equation? No, so acceleration is actually missing. So there's no point of using that equation because acceleration is not included in the equation. So that is already missing, so we're not going to waste our time on that one. Let's look at the second equation. So we know the final velocity, we do know the initial velocity, we don't know the acceleration, and we also don't know the time. So we have two unknowns and we just have one equation. So we cannot solve for two unknowns using one equation. So let's move on to the third equation. We know the final position, we know the initial position, and we know the initial velocity, and we don't know the time, and we also don't know the acceleration. So we have two unknowns, so that one doesn't work. Let's look at the last equation. We do know the final velocity, we do know the initial velocity, and we are solving for the acceleration. That one is an unknown. And we know the final position, and we also know the initial position. So that sounds good. We have just one unknown and one equation. So that's the equation we are going to use. And one equation and one unknown. So once you have the correct equation, it's really easy to execute the plan. So let's solve for A by substituting knowns and unknowns. So this is our equation, and we know the initial velocity, final velocity is 0, and initial velocity is 367 meters per second. It's positive because bullet is moving to the right, and the acceleration is an unknown. Final position 0.0621 meters, initially 0. And then I'm going to subtract 367 meters per second, the square of that, from both sides of the equation. Because I'm going to solve for acceleration, I need to separate it out. So now next you can cancel out this square of the 367 meters per second from this one, and then let's see the next step. I'm going to divide both sides by 2 times 0.0621 meters. Whatever you do to the left hand side of the equation, do the same thing to the right hand side. You basically have to do the same thing to the both sides of the equation. And then once you solve for the acceleration, you will get negative 1,084,452 meters per second squared for the acceleration. So you might be wondering how I got meters per second squared for the unit. So let me show you. You have meters squared divided by second squared, and then you have to divide that by meters. So I'm just looking at the units here, and you have meters squared on the numerator, and then meters in on the denominator. You can cancel out meters to meters, and you're left with meters per second squared. That's how you got the unit for the acceleration. And this is the standard form. I'm going to give the answer in scientific notation. So I rounded it up to 3 significant figures. Negative 1.08 into 10 to the power 6 meters per second square. Okay. So let's check and evaluate. Is the solution complete? Yes, our purpose was to calculate the acceleration. We did that. Is the sign of the answer correct? Yes, we have a negative sign for the acceleration, which makes sense because the bullet is slowing down while moving to the right. And based on the coordinate system, we should expect a negative value for the acceleration, and we got a negative value. Does the answer have the correct units? Yes, meters per second squared. And is the magnitude of the answer reasonable? So we have a large value for the acceleration. This is the acceleration of a bullet. So yes, it makes sense, it's reasonable.